This one's kind of one of those I talked to you guys earlier about what do we do if we have two radicals? How do you go about isolating a radical if you've got two of them? Just pick one of them. Okay. I'm going to give you guys a heads up. This is going to be a long problem, but you just keep following me through it, and we're going to get through this one. But there's only very few of these. You only have to get at least practice once or twice, then you'll get it down. All right. I'm going to isolate this one. So that means I need to move that term over and that term over. So I have the square root of x plus 1 is equal to the square root, now this positive, so I moved it over, of 2x minus 5. And when I move the 1 over, it becomes a negative 1. Okay, now I'm going to take very close attention. Square root of 2x minus 5 and then minus 1. The minus 1 is not underneath the radical. It's just off to itself. Okay? And at this point right here, we're going to do exactly what we would have done if we just forget what's on that right side. Because we're like, oh, square root, so I want to square, so that way I get rid of the radical. Well, that's only going to work just for a little bit further. We're going to kind of have to do this whole process twice. Okay. So squaring a square root cancels those two out, and we just get x plus 1. Now this right part right here, this is where the big star is coming in. Because what you're squaring is a base that has two terms to it. Because it's what you're squaring is 2x minus 5 minus 1 times 2x minus 5 minus 1. Okay, you have to watch out for this, because if you square a base that has more than one term, there's no other way to do it other than writing it out, and we have to distribute everything through. This is the only way you can square when your base has more than one term. Okay. If you, over here on the left, we were just squaring just this one radical. That was simple. Over here on the right, though, we have the radical and we have the minus 1. So we have two separate things going on here. Okay, so we'll leave the left the way it is. It's just x plus 1. Let's go to the right. So if I multiply first to first, and this is where we're going to get practice in, a square root times a square root when it has the exact same thing under the radicals, it's just going to be 2x minus 5. You get what's coming right back out. Okay, so now let's go the outsides. The square root of 2x minus 5 times negative 1 is just a negative square roots of 2x minus 5. Insides, again, will be a negative square root of 2x minus 5. And then last, a negative 1 times a negative 1 is a positive 1. Just like that. Okay, so this is where y'all can see it's a little bit different here. A lot more work going on here. So let's kind of keep cleaning this up. X plus 1 on the left. Over here on the right, I have the 2x. I have a minus 5 and a plus 1 from the back. So that'd be a minus 4. And then let's look right here, how to join these up. You see how it's a square root of 2x minus 5 and another one? So there's a negative 1 of it and another negative 1 of it. So it's a total of negative 2 of this. Okay. Now, what we're going to do is pretend like the problem started right here. And I gave you that problem. It has one radical in it at this point. So we're going to start this whole process. This is almost like consider this round 2. Round 2, we want to go through the exact same steps. You want to isolate your radical just like normal. So let's move this 2x over. Let's move this minus 4 over. So x minus 2x. And then it'll be a 1 and then a plus 4 this time. So x minus 2x is a negative x. 1 plus 4 is plus 5. And then over on the right, we have the negative 2 square roots of 2x minus 5. All right, we get to, at this point, because the variable or the radical is isolated, I'm going to square. Okay, and look here on the left. I'm squaring a base that has two terms. So I've got to write it out as negative x plus 5 times negative x plus 5. Over here on the right, I'm squaring a square root, but I'm also squaring a negative 2 that's out front. So when you square negative 2 times negative 2 is 4. And when I square the square root, we just get what's sitting underneath that radical, just like that. All right, we have finally gotten to the step where all my radicals are gone. So before I finish cleaning this up, let's go back to the start again. The whole goal, what we wanted to do is isolate one of them, and then we squared both sides. So we isolated the one, we squared it, got rid of one of the radicals at least, and then we FOILed out the right. And then we start the whole process again because we can only really get rid of a radical one at a time. So we isolate one, square both sides, and that eliminates one of them. After you finish foiling it out or distributing everything out, then isolate the second radical and then square both sides. And be careful that if you ever had anything in front of your radical, like in this case we had the -2, that we had to square that too. Sometimes those numbers will pop up, sometimes they won't, but we just always have to watch out for it. And then from here, it's going to be just a typical multiplying it out. So -x times -x is an x squared. Outsides would be a -5x, inside's a -5x, and a positive 25. On the right, we'll get 8x minus 20. Well, this is quadratic in nature, so we know how to solve a quadratic, first of all, by bringing everything over to one side, so we have 0 on the other. I only have one x squared term, it's just x squared. A -5x and -5x is a -10, but we also have this 8x coming over as a negative, so that'll be -18x, and 25 plus 20 is going to be 45, is equal to 0. Alright, going through, and I'm just going to factor this real quick, because the leading coefficient's a 1, so the factors of 45 that add up to -18 are going to be -15 and -3. So from this first parentheses, I'm just kind of jumping ahead just real quick, you'll get x to be 15, and from the second one, you'll get x to be 3. Alright, so before we can call these answers 100% good to go, because we have to go back and check them and make sure that when I plug them underneath that radical that I get positive numbers. So let's just go with this first radical. Let's just focus on that. If I plug in 15, 15 plus 1, definitely positive. 3 plus 1, definitely positive. So 15 works out. And 3 works out for both of those. Or both of those work out for that first one. Let's go to the second one though. 15 times 2 is 30, and 30 minus 5 is 25. That's positive. 3 times 2 is 6. 6 minus 5 is 1. That's positive. So it looks like both answers are good to go. Okay. And you know what? If your problem originally had 3 radicals, you'd be going through isolate one of the radicals, square both sides. Then you would have 2 left over. So isolate one of those 2, square both sides. Then you would finally have the third one left over. It's just however many radicals is how many times you have to go through this whole process of isolating, squaring, isolating, and squaring. Okay. All right, let's go to example 12. It looks like we're going to look at number 75 in the book. So if you don't have your book out real quick, if you'll go grab it, go pull out on page 51. Let's look at number 75 and then kind of formulate some thoughts on what it's asking us to do. We'll come right back to this point. Okay, and what I did real quick is just kind of write up some general stuff of exactly what the book says. And specifically what we're looking at is, looks like the demand of smoke alarms. So the quantity demanded, X, represents how many smoke alarms are demanded by this company. And it says specifically the X is in thousands, so that's good to know. And they give us this equation right here. And it says the amount that's demanded per week is related to the price. Well, doesn't that make sense in the world of business? You know, if the higher your price is, the less the demand is. Because who wants to buy some tennis shoes that are $500? Very few people do. But if you price those tennis shoes at $50, at least you're entertaining the idea a whole lot more. Okay? So what this is saying is that the X, which represents the amount of these smoke alarms that are demanded, is related to the price P. And we're going to give, in general, they can, looks like since it says X has to be 0 to 100, that means there's probably a cap on how much this company can actually make. Because in that problem, you see how it says that it's the smoke alarms per week. They obviously can't make more than, an X is in terms of thousands, so this is 100,000. You can't make more than 100,000 per week, so there's a little cap going on here. All right, the problem just specifically asks us to find the demand when P is equal to 10. All right, so we're not plugging 10 in for X, we're plugging 10 in for P. So go into this problem. It's going to say now that 10 is equal to 30 times 0.02 x squared plus 1. And we need to solve for x. Well, the easiest way to do this is to get rid of whatever's in the denominator is to multiply both sides by what's sitting down there. So let's multiply both sides by the 0.02 x squared plus 1. That's going to chunk that out. So 10 times 0.02 is just 0.2 x squared, moves the decimal up 1, plus 10 is equal to 30. All right, let's move the 10 to the right. Mainly, I'm not setting it equal to 0 because I only have one variable in here. It's sitting right there. So I don't really need to put it equal to 0 and solve it. I can just get it this way by just moving the constant over. So this will be 0.2x squared is equal to 20. And if I divide both sides by 0.2, then I'm going to get x squared to equal 100. And then right here, taking the square root of both sides, and remember I said anytime you do a square root, you do plus or minus. So x is equal to plus or minus 10, just like that. All right, so let's answer the question though. The question says, specifically, is what is the quantity demanded when the price is 10? Okay, so the quantity demanded, x, can either be a positive 10 or a negative 10. Let's think about that for 2 seconds. Can I ever produce a negative amount of smoke alarms? Not so much. So in this real world problem, then we can just say x is equal to 10. Or in this case, because we are specifically talking about in thousands, so you can say 10,000 alarms are in demand when P is equal to $10. Just like that. As I said, our x's are always in terms of thousands. All right, so let's go on to the next topic.